All right. So, first of all, I want to say thanks for you guys having me or allowing me the privilege of speaking here again. Um, Last time I talked on using American Fuzzy Lop to do fuzzing of binaries, and today we're going to talk about vulnerability hunting with CHIPSEC and LuvOS. So our basic agenda is going to be the intro, what CHIPSEC is, what LuvOS is, a demo, and then conclusion. So obviously, there's a great deal of importance when it comes to understanding what's going on at the firmware or flash memory level. Issues such as the Lenovo BIOS issue from a couple years ago where they left space open to be able to write stuff is just one example where someone could use insecure UEFI or BIOS settings or poorly written memory to be able to gain persistence into the system, which ultimately could prevent usability of the system, or the attacker could gain irrevocable access to the device. And obviously, learning new things is fun, which is why we're here. So, what is CHIPSEC? It's a Python and C-based tool. It checks for chip level settings to validate that it's properly configured. It looks at both your standard BIOS, UEFI, and it also looks at some of the different memories, the flash memories that are on board, and kind of gives you a little bit more information on those. And we'll get into that in a little bit more detail during the demo. So it's pretty versatile. It can be used as a separate Python module. You don't have to actually install anything. You can just build it, and it can run on Linux, Windows, and Mac. I've never ran it on Mac because it screams warnings at you that if you do this, you very well may break your system. So I advise against it. And saying that, you can do a pre-boot environment with a UEFI shell that has all of the CHIPSEC components in there with the Python environment. So the obvious benefit of that is that you don't have to install any additional software to the OS, and it prevents, if you're dealing with systems that you don't want to mess with the configurations, it prevents you from having to mess with configurations. Because, for instance, on Windows specifically, because of the new driver signing stuff and everything that has come up over the past few years, the CHIPSEC driver that you build does not have the right signatures, so you have to put it into test mode. And so putting it into test mode, obviously you're opening yourself up to some risk because you are allowing unsigned drivers to execute on the system. So here's the basic structure of CHIPSEC. At the top level, there are two, modules that you would say. There's the CHIPSEC Main and then the CHIPSEC Utility. And under the main, there, it has the different scripts, and same with the utility, it has different scripts that it talks to. And then it gets down into the hardware abstraction layer where it's making those hooks and using the OS helper to be able to talk to the actual hardware and figure out what's going on with the memory configuration or BIOS, whichever modules you're running at that time. So the main module is used basically to execute the full test suite. That's a pretty simple command, and it can also allow you to do specific module calls instead of having to do an entire test every time. If you're wanting to just test your systems for specific things, you can run it where it's just going to run certain modules. And there are multiple output formats. In the CHIPSEC Main module does provide valuable output about any chip level vulnerabilities. For instance, it will, one of the, bigger ones that they have on there is Spectre version 2, And so it provides you with that information if you have a system that you can configure in a way that is mitigating that, or if you're just kind of hosed. And the multiple outputs, as we had talked about, you can just do a log file that has all the verbose output, and that's a lot of information. The JSON file is a very simple pass-fail. It just lists the module and then pass or fail. And then the XML, similar to the log file, is a more verbose output, just a little bit easier to manipulate programmatically. And it does an excellent job of detecting misconfigurations of board level memories. So here is an example of one of the tests running just the module. So the command there that was executed was CHIPSEC Main, and then TAC M basically is to say that you just want to execute a single module. And then it performs a test to verify that the BIOS passwords are not existent in the keyboard buffer. The system that I wanted to bring here to do the demonstration with, it did have that vulnerability. It was very neat because instead of just being all zeros, then it had that all populated, and you would be able to decode it and figure out what your password was, which obviously you wouldn't want that floating around. And here is the S3 boot script for the UEFI, and it shows there at the top that it is unprotected. And so basically, it can be intercepted right during the waking of the computer when it goes to sleep. So it shows that it failed, and then you can additionally run. It tells you there that you can additionally run the tools.uefi.s3 script modify, and that will provide you more detail. And then right here you can see where it shows, basically walks through, and there's a lot going on up there. But if you follow through everything, you can see where they manipulated the data in there, and it basically allowed the information to be modified. So if that S3 boot script can be modified, then that's another way that an attacker would be able to get a foothold on the system and be able to gain access during a reboot cycle. And yeah, it's basically it just moved the terminate opcode to a different memory address for the test. So the fun one is CHIPSEC utility. But CHIPSEC utility is very dangerous because it gives you direct access to hardware. There are a bunch of scripts that you can run to get additional information about the hardware, and you can dump memory into binaries, ROMs. You can list the variables, keys for like your UEFI, KEC, and different keys like that, and all of that. That part isn't so much the danger, but you have the ability to then go in and like manipulate the memory or clear memory, which probably shouldn't be cleared unless you have a backup. So an example here is in the utility scripts there's a PCI command which allows you to enumerate and have direct access to the PCI config registers, and you can go through, and then if you're wanting to just dump a binary file from like a specific location or address, then you're able to dump that and further analyze that. And similarly with the TPM command, it can enumerate various TPM variables, and it can also dump it into a bin file, so that way you can use it. And the U code is kind of helpful if you're a low-level like microcode firmware person, because it does provide the microcode ID for the CPU and any updates. So I'm going to switch devices here real quick. All right, it's really not very easy to see, is it? So I don't know if you guys can see that very well. You can, okay. So there's basically here's the CHIPSEC Main, right? And it just rapidly goes through everything. And so in this case, you can see up there that there was the error on the S3 boot script, and then it failed the Spectre V2 check. And then there were a couple warnings as well, and that not applicable. And so, oh, that's a, hey. There. All right, so that was the CHIPSEC Main. So here we can do running just a single module, and so it shows that basically it gives you a little bit more detail on what's going on, right? It says that the module was unable to recognize that there was a resume boot script on the platform, and we can also do the secure boot variables. And so this is one that I think is always important to check, for the simple fact that you want to make sure that your UEFI variables cannot be written to without proper authentication. And in this case, this script is making sure that there is either some sort of like regular authentication, or in this case, the best is the time-based authentication for write access. All right, and then there's also the CHIPSEC util. Just so you have this whole list, right, of everything that's available, and depending on what you want to look at will depend on. So like the CHIPSEC doing just the platform basically will give you a list of all of the short codes that these short codes that it uses, and every processor that the CHIPSEC can be used on. And so this is helpful, obviously, whenever you're wanting to run tests to make sure that it's something that can benefit from it. In saying that, there is an attack eye that you can put behind the CHIPSEC Main or CHIPSEC util to ignore whatever the architecture is, so that way it'll still go through and try to run everything that it can on there. And I'll just run one more to, I think it was, oh, no, it wasn't CMOS. And so like this, all right, it'll tell you if you don't type in enough stuff, right? So I can do var list. They haven't fixed it yet. They've been going through the transition from Python 2 to Python 3, so there's a few bugs that they are still dealing with. Okay, so it wants to make me look like a fool tonight, and that's okay. But anyhow, that's the basics there of CHIPSEC, and there's a lot of documentation on it. You can go either to GitHub, wrong side, or just type in like CHIPSEC tutorial, stuff like that, and it'll pop up all kinds of good stuff.
So moral of that, you have to have physical access to the machine and have CHIPSEC installed, correct?
Yes, you do have to have, so, well, I shouldn't say yes. So you can set it up where, like, if you're able to pixie boot, it's a little bit more challenging, and kind of talking forward into the LuvOS. LuvOS is set up to do pixie booting, but again, it's a project that is open source, and the documentation is excellent. But there's certain things that I've never been able to get it to do. I've emailed back and forth with the people and done everything exactly like they say, but it just won't work for me. So basically, what I did for CHIPSEC to do just a standalone pixie boot of that was I took a Windows PE and then put I think it was MicroPython on there, and then loaded all this on, and I had to go through and set up do a BCD edit of the WinPE, so that way it would always load into test mode, and then just set up some scripts to automatically fire everything off and then dump it into an SMB share for me. So it is possible to gain access over the network, but it's easiest to do it with physical access. All right, there's the recap real quick. And so now talking about the Linux UEFI Validation OS. So it is part of the Intel open source group, 01.org. It is a live operating system, and it's really a Swiss Army knife of low-level system testing. And the nice thing about LuvOS is that it produces a very nice, neat packaged report, so that way you can just go in. It's an HTML file with little internal links and everything, so that way you can go in and you know, for display purposes, it makes it easier to explain to a manager or whoever what's going on. So the tools that are on LuvOS are BITS, the BIOS Implementation Test Suite, NDCTL. That one is one that is a dangerous one as well, because you can mess around with memory a lot. So I just have never tinkered with that other than letting it run the way that they had it set up. The firmware test suite, which is a part of Ubuntu. And then you have kernel EFI warnings. Basically, the kernel EFI warnings is just a bash script or a series of bash scripts that goes and checks for any UEFI warnings that may have been written to memory, so that way it can see, okay, is there a possible vulnerability here or something misconfigured? It's, you know, just kind of more of an informational thing. And the pstore tests, which that's specific to Linux, designed to record data at a kernel crash, and then there is also CHIPSEC on it. So it is, for anyone that uses Yocto, it is a Yocto platform. There are 3 different basic configurations: NetBoot, USB MBR, and then USB GPT. And right now they do still support 32-bit on all of those as well. And then the NetBoot is a little bit, it works great. You can pixie boot all day long, but with the NetBoot, unless you have, like, you have to have an HTTP server set up, and then you have to write an upload script and point everything during the build out, so that way whenever it runs, it reaches back and hits that upload script and pulls everything back. And that's the part that I've never been able to get to work. So maybe one of you guys that is much smarter than me will figure that out, in which case please share. So bits, you know, it allows for checking of the microcode, supports additional Python scripting if you so desire. But LuvOS does have specific scripts that it runs. And you can run it separately from the grub environment. And so basically, the way that Love works is it will execute bits before the actual loadout of LuvOS. So it'll load the bits UEFI shell and run the tests and write it off to the memory, and then it'll go through and finish loading the LuvOS. So the firmware test suite, again, it was something that was from Ubuntu or Canonical, and it can be a standalone pre-boot environment as well. They do have their own LiveOS. The benefit of having it on LuvOS is that you get more tools instead of just being the firmware test suite. It can identify BIOS, UEFI, and ACPI errors. And as you can see there on the screen now, that's running just the firmware test suite in live mode for just the firmware test suite. You can set it up for running all the tests, selecting individual tests. And I believe that the way that they have it set up on Love is that it runs most of the tests. There's a whole bunch of tests in the firmware test suite that it can take hours, if depending on how in depth you want to get. It does execute within Linux and the LiveOS, or also with LuvOS. And there are some overlaps there with CHIPSEC, which is nice to be able to validate any issues that you might see. So as we had talked a little bit ago, kernel EFI warnings is a basic shell script, and it just analyzes the dmessage buffer to find any error messages or kernel error messages that might indicate a UEFI bug. NDCTL, it checks basically the security configuration of the non-volatile DIM, and it checks. So with that, the danger comes in is that the script by itself, if you run it, you can create or destroy namespaces and alter the memory configuration, which, unless you're prepared to brick a system, I would recommend against it. And everyone loves screenshots. So this is the basic test during execution. The one on the left there, it just shows a very basic user interface where it tells you what tests are running, and then at the end, it'll give you that summary as far as the results being saved to the media. It tells you how many tests run, the number of unit tests, passed, failed, skipped, etc. So I don't think I have it on this one. Oh, whoops. So, wrapping up with more and more devices being out there, it means that there's more firmware and flash memory and things like that. That's everywhere that we need to make sure that we're aware of and are taking the appropriate measures to protect. CHIPSEC is one of those methods to be able to find any potential vulnerabilities. It does allow for that low-level memory checking, and you have the utility scripts at your disposal as well, so that way you can dig a little bit deeper into what's going on. But as stated earlier, you want to be very careful, otherwise you could turn your device into a brick. And LuvOS, since we just talked about it, provides a bunch of tools. It can be used for or used as a PXE boot to increase the overall efficiency, so that way you can test multiple hardware platforms all at the same time. It does also have CHIPSEC, and it provides a nice HTML report to be able to dig into the findings. Any questions?
Have you ever bricked a device?
Yes. my old Lenovo, I had it was a Yoga 2, and I had found that it was basically part of the memory wasn't written or overwritten, so there was open memory, and I was like, let's see what happens. Click, 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 smash, 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 dead computer. So yeah, I recommend caution because I'm not a firmware programmer or anything like that. So I knew that I could deal with it dying, but I just wanted to mess with it. So.